Hey everybody, welcome to our first set of notes on motion. You'll use these notes to answer the questions in today's assignment. We'll start off by defining a few terms. First of all, there's position. That's an object's location. And then there's motion, which is defined as a change in position. Now, linear motion is a very special term given to motion in a straight line. Kind of like these two dragsters are going to attempt to do. They're going to attempt to race in a straight line. Now, when we measure motion, we measure it two different ways. The first and the most common way that we measure it is by talking about distance. Distance is defined as the measure of a change in position, and it's always along the path moved by an object. So you go from start all the way to finish, and all the curves and turns all count. You add up the total distance moved. That would be distance. And all you get for an answer is a number with units, like 10 meters, 40 miles, 35 kilometers, something like that. Displacement, on the other hand, is another way of measuring motion. But for displacement, we measure a change in position that's a straight line from the start to the ending point. So from where you started, straight to where you end. That would be the displacement. And displacement includes direction. The path that you take to get there doesn't matter. So you really don't get credit for all the work you do getting there. It's just measured straight from the beginning point to the end point. Let's work through an example. Pamela rides her bike from home to her grandmother's house that's 150 meters to the north. She then rides to the store 250 meters to the east. Next, Pamela rides to her cousin's house that's 150 meters to the south. And we have two questions. What distance does Pamela travel? And how much is Pamela displaced from home? So let's look at how we would go about solving it. First of all, the distance. Well, the best thing to do is to draw a picture of what she does. We'll draw an arrow that's 150 meters north, one that's 250 meters east, another one that's 150 meters south. Now, in order to find her distance, we just add them up, start to finish, 150 plus 250 plus 150. She traveled 550 meters. On the other hand, if we want to know how much she's displaced from home, her displacement is straight from start to finish, which is only 250 meters to the east. Notice that we have both a distance and a direction. Now is a chance for you to show that you understand what we're talking about. So this one's one for you to answer. Natalia begins at the start line and she runs around a 200-meter track 2 times. Okay, this means that from where she started all the way around and back to where she started is 200 meters. And she does that 2 times. But she stops exactly where she started, right on the starting line. So in your notes, the first question we want you to answer is, what's the distance Natalia runs? Then the second one, what's Natalia's displacement? We also want to practice with one more question. This one has Emerson riding his bike from home to his grandmother's house 50 meters to the east. Then he rides to the store 179 meters north. And finally, he rides to his cousin's house 50 meters to the west. So east, north, back to the west. So in your notes, answer both questions. What distance does Emerson travel? And how much is Emerson displaced from home? Figure out both of those and write them, or type them, I should say, in your notes. Now let's talk about changes in position and how fast position changes. When we talk about that, we're usually talking about speed. Speed is how fast something's moving. We say it's a rate of motion because anytime we talk about how quickly something's happening, it's a rate. And in speed, It's distance divided by time. The distance something travels divided by the time spent traveling it. So that gives us a formula of V equals D over T. And I know distance doesn't start with V, velocity does, but they're not exactly the same. Speed is simply how fast. Velocity is how fast in a certain direction. We'll get to it a little later, but we use the same formula, same symbol. Now, speed's units will always be some units of distance over some units of time. So it could be meters per second, kilometers per hour, miles per hour, foot per second, or any other measure of distance divided by any measure of time. Meters per second is in red because in physical science class and most science classes, that's the one that we use the most often. And you even see a picture up here in the corner of a speedometer in a car. And notice it's like a lot of them nowadays. MPH stands for miles per hour, those big numbers, and then km/h, kilometers per hour. So a lot of them will register both. And the digital ones you can switch back and forth in. Now when we calculate speed, of course, we looked at just the most basic formula, speed equals distance over time. Well, we can arrange the three variables in that cool little triangle. We've used that in class before. And we know that if we're trying to find speed, then distance over time is the correct formula. If we're trying to find distance, then it's speed times time. And of course, if we're trying to find time, distance is over speed. Just remember, keep track of your units. Let's see how this all works out. How do we use one? We'll do an example. Let's say Davey drives 80 miles in 2 hours. What's his speed? Well, the first thing you do anytime you solve a problem in science class is to write the formula. You know that. We've done that for a whole quarter. We know that there's always credit given for every time you write a formula, so don't forget. And just because we're on a computer, you can still write the formula, just type it. That's what I did. V equals D. I highlighted D and underlined it, and then hit return, came back to the next line and typed a T. So if you play with it a little bit, you can get it to line up and it'll be just fine. After the formula, we always have to fill in. The unknown equals, notice Davey drove 80 miles, so where D was, I have 80 miles. I have the line. And then where T was, I have 2 hours. Then we do the math. 80 divided by 2 is, of course, 40. And the units, miles over hours, is still miles over hours. Nothing cancels out there, so you write the whole thing. Miles per hour. So the answer is Davey goes 40 miles an hour. Now it's time for you to do one. You'll see this problem in your assignment. Taylor drives 58 miles in a half an hour, or 0.5 hours. What's Taylor's speed? Remember, you've got to show me 3 things. The formula, the numbers filled in with the right units, and the answer with the right units. All right, so get that assignment done. Remember, you can go back and forth through this video as many times as you need. And when you're done, you will have that paper, which will serve as your notes, but also you submit it, and that will be your first grade of this unit. It'll be a low-level grade out of 20 points. Have a great day.